My students, how have you been? I wish you are good. Today, you'll start the second lesson of Unit 2, Accompanied Forces to Motion. And here we have three forces which accompanied to motion. The first is called inertia, and the second friction, the third inside living organisms. Let's watch this video together.
We need to look at Newton's first law of motion again. Here it is. In simple words, this means that objects tend to keep on doing what they are doing. It is the natural tendency of every object to resist change in their state of motion. If they are at rest, they would prefer staying at rest, and if they are moving at a constant velocity, they would want to continue doing so. This tendency of objects is called nothing but inertia. It's the natural tendency of an object to resist change in its state of motion. Yes, you already knew what inertia is. And yes, Newton's first law of motion is also called the law of inertia. Do you think all objects have the same inertia? All objects resist changes to their state of motion, right? So all should have the same inertia, correct? Well, not really. Because inertia tells us how strong an object's tendency is to resist change in its state of motion. Think of it like this. There's a tiny brick kept on a table next to a relatively larger and a heavier brick. Which one do you think would be easier to push?
Without doubt, the tiny brick, correct?
Yes, but why is that? It's because the heavier brick's tendency to resist change in motion is more. The heavier the object, the more is its tendency to resist the change in motion. The more mass an object has, greater will be its inertia. We need to
And now we can say that the force of inertia, it's a resistance of object. Okay, this is object. Okay, to change its phase from rest to motion or vice versa. Okay. Excellent work. And now let's take some examples of inertia. Here we have passengers and driver. In moving, bus are pushed forward when bus stops suddenly. The explanation that the bus stops suddenly, passengers and drivers resist change of their state from motion to rest. So this is the resistance. This is inertia. And we have another example. Passengers and drivers in a static bus are pushed back once bus start moving forward. Why? The explanation because of inertia. Why passengers and drivers resist change from their state from rest to motion. Okay. And now let's take this example. Football player rushes forward and falls on the ground if he is tripped during running. The explanation: due to force of inertia, the body of player resisting changing of its state from motion to rest, as we can see. Okay, and here we have the fourth example. If you carry a plastic cup of your palm, when you walk forward fast and stop suddenly, cups will move forward and fall. The explanation: due to force of inertia, okay, so, that cups resist change in their state from rest to motion. And now let's take the second force which accompanied force to motion, and it's called friction force. Actually, we have feedback on the friction force because we studied it in Prime 5. And let's watch this video together to can remember.
Move in real life? Say a ball is moving on a flat ground and there's no external force acting on it. Will the ball eventually come to a halt? Yes, it will. Have you ever wondered why? Say you're skating on an ice rink and your friend is skating on the road. Whose movement do you think will be smoother? Definitely yours. When you hold a bottle in your hand, why doesn't it just slip through and fall? Sometimes when you're walking around in a mall, do you remember seeing a caution sign to warn you about the floor being wet? What explains all this? The answer is friction. The reason why the ball eventually comes to a halt is because of the force of friction. The reason why skating on an ice rink is easier because the force of friction is lesser there. The bottle doesn't slip through because the force of friction between your hand and the bottle doesn't allow it to do so. If the floor is wet, the friction offered by it reduces and there are chances that you might slip and fall. So what is this friction we're talking about? It's quite easy to understand its concept. Friction is nothing but a force. It is the force exerted by a surface where an object moves across it. In the first case, when the ball is moving in this direction, the force of friction is acting in the opposite direction. The force of friction offered by the ice rink floor is lesser than the force of friction offered by the road. Hence, skating on the ice rink is easier and seems effortless. The bottle does not slip down because the surface of your hand offers a friction in the upward direction. And in the case of the floor in the mall, the soapy water reduces the friction offered by the floor.
And now we can talk about the friction force and say it's a resistance force. Why resistance force? Because it's against the direction of motion and originated between two touching surfaces, here the object and the medium. For example, here we have the ice cube moves easily than rubber on a table. By using brakes on the car and bike, they stop moving in a short time. We have benefits of friction. First, it prevents feet from slipping during walking. And second, friction between brakes and tires stop its motion. Okay, and here friction between the car tires and the ground helps starting car motion and stop of it. And here it helps in burning of match. And we have harms of friction: loss of mechanical energy as it changes into a heat energy. When this machine works for a long time, it generates heat. Okay, so some of mechanical energy changes into heat energy. It produces heat energy between the parts of machine because here friction. Okay, and this may lead to erosion and damage the internal parts of the machine. Okay, how to limit the friction force, how to decrease the friction force, so decrease the damage in the internal parts. We use lubricant by lubricating and oiling machines, okay, or mechanical machines like this. This is called lubricating. And here we will talk about the forces inside living organisms systems. Okay, here it may be simple systems or complex systems. Simple system like unicellular organisms like amoeba, paramecium, euglena, and complex like multicellular living organisms. And here importance of forces inside living systems enable living organisms doing its biological operations, and here keeps its survival and vitality. For example, here contraction and relaxation of the heart muscles, as we can see, to pump blood all over the body. Okay, and here pulse inside body vessels, as we can see here. Okay, and transportation of liquids through pores and walls of cells from lower concentration to higher one, like this. And in number 4, contraction and relaxation of body muscles to help the body organs movement. Now this is the time for to-do list. Watch the session another time and read the materials to solve the homework. See you next session.